Hi, and welcome to day 5 of Applications of Calculus. So today we're going to start talking about curve sketching. Our understanding goal is to sketch a curve by using the first derivative and without the use of a GDC or a graphing calculator. Curve sketching. Suppose S is an interval in the domain of f of x, so f of x is defined for all x in S. If f of x is increasing on S, then if and only if, that's what my double-sided arrow stands for, f of a is less than f of b for all a and b as an element an element in S such that a is less than b. If f of x is decreasing on S, if and only if f of a is greater than f of b for all a and b that are elements of S such that a is less than b. Okay. Basically, all that's saying is your y values, because your f of a and f of b are just your y values. For the first one would be getting larger as you went from left to right. And if your y values were getting larger, your function would be increasing. If your y values, f of a is greater than f of b, are getting smaller, then your function will be decreasing. So we can deduce when a curve is increasing or decreasing by considering f prime of x on the interval in question. For most functions that we deal with in this course, f of x is increasing on the interval if and only if the derivative is greater than or equal to 0 for all x in S, and f of x is decreasing on S if and only if the derivative, f prime of x, is less than or equal to 0 for all x in S. So what that's saying is if your derivative is positive, then your function is increasing. If your derivative is negative, then your function is decreasing. All right, monotonicity. Many functions are either increasing or decreasing for all x as an element of the real numbers. That stands for real numbers. We say these functions are monotone increasing or monotone decreasing. So for example, try my axes here. This is y. This is x. There's my function. So we'll say that this is y equals 2 to the x. This would be monotone increasing because the function is always increasing from left to right. So this could be y equals 3 to the negative x. And this would be something that would be considered monotone decreasing because the function is always decreasing from left to right. Pretty simple. All right, find the intervals where f of x is increasing and decreasing. So just by looking at the function, my function is increasing from here to here, and again from here to here. So that's where my function is increasing. It's increasing from negative infinity to negative 1. I have a soft bracket for infinity because it can't be equal to it. I have hard brackets for something that it's equal to. Union 2 to infinity. Okay, basically what this is saying is x is less than or equal to negative 1, and x is greater than or equal to 2. So it's just two different ways to say the same thing. this function is decreasing, well, it's going to be decreasing right through there. So my function is decreasing from -1 to 2. And I'm just going to kind of put this in here so we can see the difference. This includes endpoints. And this excludes endpoints. And this is just interval notation. You need to be able to recognize it and know what it means. For this problem, this is our answer. I just want you to see the difference between the two intervals. Okay? Alright, for example number 2, find the intervals for where the following functions are increasing or decreasing. Well, in order to do that, we have to find the first derivative. So the derivative of my function is going to be -3x squared plus 6x. Then I want you to take and find where your derivative is equal to 0. I'm going to factor out a -3x as a GCF. So I'm left with x minus 2. Basically what I'm doing is a sign diagram, like we were doing before. And I'm just going to do it a little bit differently. I'm going to draw a number line for each of my factors. And then one to put my factors together again. So my first number line will be 0 at 0. If I put a number in for x that's less than 0, and -3 times, I don't know, say for example -10, I'm going to end up with a positive value. So anything to the left of 0 is positive. If I put a number greater than 0, like +10, -3 times 10 is -30. So anything to the right of 0 is negative. X minus 2 is equal to 0 at 2. If I put a number in less than 2, for example 0, I get 0 minus 2 equals -2, so that would be negative. If I put a number greater than 0 in, 10, 10 minus 2 is 8, and that's positive. So now I'm going to take and combine my two number lines, because that'll give me an overall view of the whole function. I just kind of draw my squiggly lines there to separate things. A positive times a negative is a negative. A negative times a negative is a positive, and a negative times a positive is a negative. I just multiply my number lines together instead of picking values and substituting into my functions and then risking possibly doing the arithmetic wrong because of negative numbers. I am just simply doing positives and negatives to get me my answers. So where my first derivative is negative, my function is decreasing. Where my first derivative is positive, my function is increasing. And then again here it is decreasing. And I believe it has to find increasing or decreasing. So we are increasing on the interval from 0 to 2 with hard brackets, because I'm including 0 and 2 because I'm not undefined at those spots. My function is decreasing from -infinity to 0, union, 2 to positive infinity. Negative infinity over there. Okay? Alright, going back up to b, my first derivative is going to be 12x cubed minus 24x. simplify it, factor it. 12x squared is my GCF. I'm left with x minus 2. So my first number line is going to be for 12x squared, and that's equal to 0 at 0. And then I have x minus 2, and that's equal to 0 when x is 2. Now, if I put in a negative number for x, say negative 5, and I square it, I get positive 25 times 12. That's going to be a positive number. If I put a number in greater than 0, like 2, and I square it, that's 4 times 12 is a positive number. So this number line is always positive. Next number line, if I put a number in less than 2, 0 would give me negative. If I put a number in greater than 2, it would give me positive. So if I draw my number line for 12x squared times x minus 2, and multiply my two number lines together, positive times negative is positive, is negative. Yikes. That's a negative. Positive times positive is still negative, and positive times positive is positive. So I am decreasing, decreasing, increasing. So the actual intervals, I'm increasing from 2 to infinity, and I'm decreasing from negative infinity to 2. Not too bad. The next one gets a little bit trickier. It says consider f of x equals 2x minus 3 over x squared plus 2x minus 3. Show that f prime of x is equal to negative 2x times x minus 3 over x plus 3 squared times x minus 1 squared. Hence, find the intervals where y equals f of x is increasing or decreasing. Well, the good news is they're telling you what the derivative is. So when you take your derivative, this is what your answer needs to look like. You have a goal. If you can't get your answer to look like this, there's a problem. Should you not get your answer to look like this, you can still get partial credit in the exam if you do part B without a problem. And typically this is what you see for a question like this on the exam. So we have a fraction, which means we need to use our quotient rule. So f prime of x is equal to low, which is x squared plus 2x minus 3. Get high, the derivative of the high is 2, minus high, which is 2x minus 3, times below, which is 2x plus 2, all over logo. The whole thing is a quantity squared. Alright, this is where the fun part comes in. Distribute your 2. 2x squared plus 4x minus 6 minus, I need to double distribution or FOIL it, and I will get 4x squared plus 4x minus 6x minus 6 all over. Now I'm going to break this up because x squared plus 2x minus 3 actually factors to x plus 3 and x minus 1. And since I'm squaring my whole denominator, I would have 2 of those, which means I'd give each one of those squared. Now that matches the denominator that they give me to work with. So let's continue to clean up the numerator. 2x squared plus 4x minus 6. I'm going to combine like terms and distribute my ones. Minus 4x squared. And that becomes minus 2x. So multiplied by negative, I get plus 2x. And my minus 6 becomes a plus 6 all over x plus 3 squared, x minus 1 squared. My 6's cancel out. And I'm going to combine like terms, and I will get negative 2x squared plus 6x over my same noxious denominator. And yes, you need to include the denominator with every step of the problem. And then I'm going to factor a negative 2x on there as GCL. So negative 2x times x minus 3 all over x plus 3, the quantity squared, times x minus 1, the quantity squared. And that matches what they told me to show. Good news. Now I have to find my intervals of increasing and decreasing. Well, I'm going to do my number lines. So I have negative 2x, and that would be equal to 0. And then I have x minus 3, and that would be equal to 3. Oh, well, isn't that strange? Fix that in a second. Okay, and this would be x plus 3, quantity squared. That would be equal to 0 at negative 3. And then I still have one more factor, which is x minus 1. And that would be equal to 0 at 1. So now I have one number line for each factor. If I put in a negative number for the first line, I will end up with a positive. Put in a positive number, I end up with a negative. On my x minus 3, I put in a number less than 3, I'll get a negative. Put a number greater than 3, I'd get a positive. For my next two number lines, everything's going to be positive because no matter what value I put in, I have to square it at the end, so that's positive. And same thing for this one. Now, if I wasn't squaring those, that wouldn't happen. So my final number line will have negative 3, 0, 1, and positive 3 on it. Kind of just to help myself line everything up. Negative 3, my 0, my 1, and my 3. So a positive times a negative is a negative, times another positive is still negative, times another positive is still negative. So that's negative. Positive times negative times positive times positive is negative. Negative times negative times positive is positive. Negative times, it's still negative, is positive times positive is positive. And then negative times positive times positive times positive is negative. So I am increasing from, let's see here, we cannot include 1 and we cannot include negative 3 because a function is undefined at those values, because that's where my zeros would be and my numerator. So if I have, my denominator, if I have a 0 into my denominator, my function is undefined. So from 0 to and not including 1, I'm increasing. And then from 1 to, that's a union, from 1 to 3, and I'm including 3. I'm increasing. I am decreasing from negative infinity to negative 3, which I am not going to include. And then again from negative 3 to 0, which I can include. It's decreasing. And then I'm decreasing again from 3 to positive infinity. Alright, the whole idea here is basically take a derivative. Once you get your derivative, find your zeros of your derivative, make your number lines, figure out where your function is positive or negative. Where your function is positive, your original function is increasing. Your derivative is negative, then your original function is decreasing.